Hello everybody. Today I'm going to do a video about something that's mechanical but isn't a clock. So from time to time I get asked if I can do repairs of mechanical stuff that aren't really clocks. And often I do say yes because yeah, if it is similar to a clock, then I am probably able to repair it. And this was the case with this contraption. This is a fully mechanical rotisserie apparatus. So the way that it basically works is you have in here you have a big mainspring, which is so big that you even need to wind it with with a reduction, so you have enough force, because here this is the lever to wind it, so it's not, you don't get that much leverage, so they build in a reduction and then the power is slowly released through those weights that get to spin around. I will show you this later. I'm about to put this clock back together. Well, clock, kind of clock. But before I do want to show a bit of like oddities, which I can only show now. So for starters, the axle, where the mainspring winds around. So here you can see the hook. This part on the axle itself is wood. So I don't know why, was this a later repair or something, but yeah, this piece is wood, and then the hook is basically a nail which they punch through the wood, and then they bend it over, and they filed it down a bit to make the hook. So yeah, this is the main axle. You can see there's the ratchet mechanism. Well, you can hear it. Here you can see the ratchet doing its thing. And so this is the gear where the next gear takes its power from, and this is the gear that's used in conjunction with this to get to the gear reduction, so you can wind it easily. Well, you still need some force. And then this gear directly drives also the rotisserie itself. So behind here there's a gear. So basically they're doing a reduction to down to this weight to get a kind of a basic escapement, but they are taking off the power still straight from the mainspring to drive the rotisserie itself, which is kind of interesting. And like down here there is one of the axles that comes through, which also can be used to, I presume, to turn something that's secondary and a little bit lighter, because down there there's already less force. And then before I put it together, there's another oddity I wanted to show you. So the escapement is basically um, a worm wheel mechanism, and normally it is the gear that is driven by the worm, but in this case it's opposite. So you can see it has a really odd tooth shape on there, in order to make that possible, because normally if you drive the worm wheel from the gear, it blocks. Normally you drive the wheel from the worm, but yeah, in this case, because they put teeth on an angle, it works. It doesn't work perfectly, but apparently it was good enough. Like, it's not, this is something that, like, it needs to turn for X amount of time. There's no precision, the only thing they want is they want to have it turning in a controlled manner. So that's why there's weights out there for to have like a bit of like you can. It's actually a bit of like a counterweight. So you make this turn, so the rest turns at a rather constant speed. There's also on here you see there's that one tooth that intervenes with this gear here, and it has a solid piece here. You can see there's a solid piece there, and that is made in a way so you can put pre-tension on there, and then you have X amount of turns, and then it will stop. But it also means that you can't wind it too hard. So it's basically the Geneva stopwork, but a very rudimentary version of a Geneva stopwork. Probably will take a picture of it and put it in the video so you can see it better than it is now. But yeah, I'm going to put this together and then I will show you the workings of it. So yeah, see you then. So here we are at the rotisserie mounted together. Normally here there are side panels to keep the grease out. They are just slot in here and there, and there's a top with like a handle like this, so it goes on top. But I'm showing you this like this because it shows like the internals, it shows it working. So here we have the basic escapement, and then the reduction. So basically, I talked earlier about like this is the axle that goes into the main barrel, which is this, and then this gear is for winding, and this gear is to release the power, and like the ratchet is in the middle. And you can see it's going, so it's spinning happily. So this is normally where the like the meat would go, whatever you put on there. And yeah, this is. So if I wind it, you can see this gear, and you can hear the ratchet. It's moving, and there's a reduction on it because it's a very strong mainspring. So yeah, and what's also odd is there is a secondary ratchet mechanism on here. You can see here it's iron on iron, but doesn't really matter. And basically, it prevents you from turning it in the wrong direction. I don't really know why that would be a problem, but it's there. Yeah, you can see it wobble around because I haven't bolted it to the underside, but yeah. So I'm going to like get it for the camera of the tripod and show you around a bit to the more interesting bits. But yeah, it's working. That's already great. So yeah, this is the escapement, and then I don't know if you can see, yeah, there on the other side you can see the counterweights. It's happily spinning around. And yeah, basically it lifts it up, so it lifts the axle with the counterweights up, so they're actually kind of free spinning. Yeah, it is slowing down because we are nearing the end of the mainspring. But yeah, and then like a quick detail on like the two gears. So actually it taps right off from like the part where the meat would go, taps right off from the main gear that's on the main spring. And this is then the thing that winds it, and then down here you can see the like a basic like Geneva stopwork, so you can have like a pre-tension on there, because This escapement is like very far from ideal, and it kind of needs some like force before it can start. So it needs a lot of force before like it starts running. And then yeah, on this side, it's not much to see actually. Like you can see the like this is what holds the escapement in place, and then these are just the bushings where the axles run in. And yes, the handle does move while it's releasing the force, so yeah, you need to be careful. That's maybe why there's a ratchet on there, I don't know. And yeah, I don't think seeing it from this side, it's something. It's not really too interesting. I need to put a lot of grease on there because, like on the escapement itself, because it is, like I said before, far from ideal. But yeah, that was the look at the rotisserie. It was an interesting repair, got to tell that. And yeah, the customer will be really happy with it. Because yeah, the customer is wanting to use this for the real deal. It's not going to be sitting in a museum. Always fun when something like this gets alive for what it was actually meant to do, despite it being like, I don't know, maybe 100 years old or something like that. But yeah, thanks for watching. I hope you enjoyed the video as much as I enjoyed preparing this, and I will see you in the next one. The next one will probably be a clock. Bye!